everyone, it's Alyssa and welcome to You Can Learn Math. Today's lesson is on multiplying and dividing rational expressions. When you look at these problems, they're going to look scary. They're going to be like, no, the horror. They're really not that bad once you get to the end of them. The beginning, the main part of this is going to be factoring. Now, if you are not 100% comfortable with factoring or like, I got this with factoring, please go either practice some more or I've got a ton of videos I'm going to link down below on factoring. You're going to need it because that's all this is factoring once you get to the heavy duty stuff. The other main principle we're going to be working with is cancellation. We're talking about fractions. This goes back to when you're multiplying just regular fractions without rationals. Like let's say if it was 1 over 3 times 3 over 7, and your teacher says, oh, well, if you have the same number on top and bottom, you can cancel it out. That's a really thin red. Let's change that. That's just pitiful. There we go. You can cancel them out. And you go, oh, like that. 1 times 1 is 1. 1 times 7 is 7. Another example would be if you had something like, say, 3 over 16, oh, not equals, times 8 over 9. You say, oh, well, 3 goes into 3 one time, and it goes into 9 3 times, and 8 goes into 16 2 times, but into 8 one time. 1 times 1 is 1, 2 times 3 is 6. That's the principle we're going to be working with. That's what's going on here. This only works when things are being multiplied. We can't cancel when things are being added. So when we are multiplying rational expressions, there's going to be a ton of canceling. The simple ones, which are not going to last long, don't get your hopes up, will be something that are like a combo of what we just saw, like say 3/16 times 8/9, but then they add in like an x squared, y cubed, x to the 4th, x to the 7th, y, and put like a y there, and maybe like a y squared there, something like that. And it's just like cancel out everything you can. Now you can, in this particular case, you can, if you wanted to, multiply everything together and then simplify it. But it's a good idea just to get in the habit of just canceling everything that you can right off the bat. And so for the numbers, it's going to behave the same way for the constants, just like we did before. So 3 goes into 3 one time, goes into 9 3 times. 8 goes into 8 one time, goes into 16 2 times. Okay, now for the x's and the y's. How many x's do I have on top? I've got 2 there and 4 there. How many x's do I have on the bottom? I have 7. So I have 6 total on the top, 7 on the bottom. You can cancel out the lower number of x's. So if there's 6 on top and 7 on the bottom, I can cancel 6 x's from both top and bottom. Because what we're saying on top is I've got 1, 2, 3, 4, 5, 6 x's being multiplied together. And on the bottom, yeah, I'm going to write them all out because I'm insane. I have 7. 1, 2, 3, 4, 5, 7. 7 x's on the bottom. So cancel out 6 of them. And I'm left with 1 on the bottom. So that's going to be how it is. You always cancel out the lower number. They just disappear. So x squared next to the 4th, bye-bye. They just leave 1 behind. X to the 7th, 6 of those x's are gone, leaving 1 x. Now for the y's. I've got 1 y there and 2 y's there, 3 y's total. On the bottom, I have 3 and 1, or 4 y's total. 3 on the top, 4 on the bottom. I can get rid of 3 y's. 3 is the lower number. So all those y's are gone, those 3 y's are gone, and I get rid of 3 y's on the bottom, leaving 1 y. Now I know in this couple cases I showed you, I just ended up with 1 on the top. That's unlikely. That's just my fault for not making something more interesting. So we all have 1's on the top, multiplied together. On the bottom, I have 2 times 1 times 3 times x times y. 2 times 1 times 3. Yeah. 2 times 1 times 3 is 6. And then just an x and a y. I know it's a lot of lines going everywhere. It's going to be less about it being hard and more about being accurate and careful. So very quickly, they're going to do something like this. They're going to say x plus 3 over x plus 1, times x plus 2 times x plus 2 over x plus 3. Okay, something like that. Well, now you're like, oh, but things are being added, so I can't cancel. You said we couldn't cancel if things were added. Okay, you can cancel if things are being multiplied. Everything in this parentheses is being multiplied by everything in this parentheses. So if something in a parentheses matches another something in a parentheses, those whole parentheses can be canceled out because the whole shebang inside that parentheses is being multiplied. So again, top and bottom, we got x plus 2 and an x plus 2, x plus 3 and an x plus 3 on top, and 1 is all that's left. On bottom, it's x plus 1. This is what you're going to be doing. Now, here I'm presenting it to you factored just to show you the principle of it. They're going to be giving you a ton of these that are not factored. So the name of the game here is going to be, let's factor everything we can, and then we're going to start canceling out. And I'm really only going to go through this the one time because multiplication and division are two sides of the same coin. The only difference, and there's only one, and it's tiny, is this. If I was given, say, something very similar, actually, let's just back it up. Let's just back it up to what I already had up here. If I had this, and let's say, make this other one a little bit different. Let's say if it was divided by x plus 2, or no. I'll say x plus 3 over x plus 2. The only thing different you do when it's divided, this is it, is before you start canceling, you take what's after the divide symbol and you flip it. Just like with regular old fractions, if I was to say 1/2 divided by 2/7, I have to flip the 2/7 and then I multiply. And that's how you divide by something with fractions. It's exactly the same. Nothing is different. They're still fractions. They just have variables in them. So all you would do in this case is you would flip it. And so then it's going to be times x plus 2 over x plus 3. That's it. And flip the one after the division sign. Okay, so let me show you one of these that is what you're going to be seeing. All right, so let's say x squared minus 10x plus 25 all over 10x minus 100 times x minus 10 times 45, over 45 minus 9x. Okay, and don't get me wrong, this isn't as complicated as they get. Sometimes they'll add even another thing over here. The process is always going to be the same. You just factor everything you can get your hands on, and then you start canceling. Frankly, when it gets to the canceling part, I know I'm weird, but I find that kind of fun because it's just like, I thought this was complicated, but no, I cancel you all out. Yeah, I'm strange. I know. You don't have to tell me. All right, so we're going to cancel. Not yet. I wish. We're going to factor this on top. X squared minus 10x plus 25. Now, I look at this and I go, oh, that's a perfect square because I see the little pattern. If you don't see the little pattern, that's fine. You can just factor it normally by asking yourself what multiplies to positive 25 but adds to negative 10. And that is negative 5 times negative 5. So x minus 5 squared, x minus 5 times x minus 5. Again, if any of this factoring stuff is going, what? Please, watch the videos below first and practice the factoring. You're going to need it in this. Okay, this one. You might go, well, like, how can I factor? There's no x squared. When that happens, you're going to look for a greatest common factor so you can pull something out. Is there a number that goes into both 10x and negative 100? Yes, it's 10. So I pull out 10, and that leaves x minus 10 behind. On to the next one. Got an x minus 10 on top. That doesn't need to be factored. You know, it's already as simple as it can get. So when you have ones like this, like the 45 minus the 9x, okay, first off, they're being a little mean because it should be written more like negative 9x plus 45. X should be first. Anytime you see this, when you're doing this, when you go, negative 9x plus 45, what goes into there? If there is a negative in front of that x, whatever you pull out, please pull out something negative. So the x is positive inside the parentheses, because that's what you're going to be canceling, things with positive x's. Just go ahead and do it. So negative 9x plus 45, pull out the negative 9 out of the negative 9x. So pull out the negative 9, and then you're left with x minus 5. So that's what I'm going to put over here. Negative 9 times x minus 5. Do that every time. Don't just go like, 9, let me pull out 9. If there's a negative in front of that x, negative in front of the x, pull out the negative with that number. Okay, and now we are in cancel time, where we just cancel things. Okay, there's an x minus 10 on the bottom, x minus 10 on the top, an x minus 5 on the top, an x minus 5 on the bottom. That's everything. So all that I have left on top is x minus 5, and on the bottom I have 10 times negative 9, or negative 90. I'm just going to put the little negative out front. So x minus 5 over 90. Again, no matter how complicated these may seem or how they may look, it's just going to be the same process over and over again. And I'll do one more. I know I said I'd only do one, but I'm allowed to change my mind. So here's one. Let's say, what if I had 8v minus 56 all over 8v plus 48 divided by v squared plus 9v plus 18, that's supposed to be a v, all over 8v squared plus 24v. Okay, again, division. Only thing I need to do to make this just like a plain old multiplication is I go, division. I look at what comes immediately after the division and I flip it. So flipped becomes 8v squared plus 24v all over v squared plus 9v plus 18. And now it's a times. Yay! But I'm going to put it as a dot because, you know, x's abound in algebra, which is why they start using dots to multiply. Don't you think that's like unfair? You teach kids x means multiply and then like never use x to multiply again. I was like, but why? I digress. It's what I do. Right. So now we start factoring. Over on the left, the 8v minus 56 over 8v plus 48. There's not any sort of major factoring like a v squared, you know, where you have to separate into two things in parentheses. So let's look for a greatest common factor. Both of these are positive v's, so I'm going to be pulling out a positive number because I want to make my v that's left behind positive. So 8v minus 56, 8 comes out of both of those. I'm left with v minus 7. On the bottom, 8v and 48, 8 goes into both of those. V plus 6. All right, on this side, 8v squared plus 24v. This, because it doesn't have the constant, the plain number on the end, you're not going to be doing any sort of factoring with things with parentheses. You're going to, though, English. You are going to pull out a v, though. I can talk. So what goes into 8 and 24? 8. I pull that out. I am left behind 1 and 3. What goes into v and v squared? Just a v. Kind of like when we're canceling top and bottom, you use the lower number. So v and v squared, I can pull out 1v. And I'm leaving behind a v and no v. So 1v, that looks like a Roman numeral 4. I'm going to get rid of that 1 because it's an understood 1. Left with v plus 3 on the inside of the parentheses. On the bottom, v squared plus 9v plus 18. I'm factoring what multiplies to 18 but adds to 9. That would be 6 and 3. So v plus 6 times v plus 3. Something to look out for with these, if you're ever having problems factoring, and let's say it's like one of those where you have 3 things being multiplied together and there's stuff up above and down below and it's huge and it's massive and it's taking you forever. If you get stuck on one of these factoring points, if you're like, oh, I just don't know what goes into this, or what multiplies to 18 adds to 9, my brain's not working. Look at what has already been given to you. Look what's above, what is potentially going to cancel it out. You'll get hints. So like, for example, here, there's a v plus 3 up on top, and there's a v minus 7. So I'm going to try, if I'm stuck on factoring this bottom one, the v squared plus 9v plus 18, if I get stuck on that, I'm going to say, would positive 3 or negative 7 work as a factor here? Because these things are designed to cancel out. They're not going to make you factor all this and then have nothing cancel out. While that might happen if this were a real world problem, they're not going to do it in a math book. All right, so this one, the v plus 3 and v plus 3 cancels out. They cancel out. The 8s cancel out. And I am left with 8v times v minus 7 on the top and v plus 6 times v plus 6 on the bottom. Not a lot of canceling in that one, but there's still some. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.